let's run through this warm up real quick because it's pretty similar to one of the methods we're going to use today. So we have four terms. The first two share a common factor of x squared. So I'm going to factor that out, which would leave me with 5x plus 2. And then my second two, well, I kind of have to factor something out, but I already have a 5x plus 2 that I don't want to change. So I'm going to factor out a 1 because that won't change anything. And then I can see that both of these groups share a factor of 5x plus 2 that I'm going to factor out of them, which will give me 5x plus 2 times, if you look at what's left, x squared plus 1. You could have also rearranged and reordered them and grouped them differently, but that's what I did. So what we're doing today is taking a trinomial and seeing if it'll factor into two binomials. So we've done a lot of multiplying two binomials together. If I give you something like x plus 5 times 2x plus 3, you know that you have to use distributive property and multiply it together. So you're going from two binomials to a trinomial with three terms. Factoring a trinomial is essentially going backwards. I'm going to see if I can figure out what two binomials would multiply together to get me that. I am going to show you two methods, one of which is basically guessing and checking, and the other one is using grouping. So first off, I'm going to do this with guessing and checking. So I'm going to guess two binomials that I think could multiply to get me this. Things that I know for sure are that if I think about how binomials get multiplied, my first two terms are going to have to multiply to get me x squared. Other things I know, my last two terms are going to multiply to get me my constant. So those two are going to have to multiply to get me 8. So maybe 4 and 2, 8 and 1, not entirely sure. So based on those facts, I can make some educated guesses. There are a couple of possibilities, not a ton on this one. If I'm going to get x squared, I essentially have to have x and x. To multiply to 8, I'm going to try 8 and 1. Checking just consists of multiplying it back together and seeing if it gets you the trinomial that we were supposed to have or not. So this would give me x squared plus x plus 8x plus 8, which gives me x squared plus 9x plus 8, which is not equal to my original trinomial. So we are going to have to guess again. So guess something else. It still has to be x and x because those are the only factors of x squared. But 8 could be 4 and 2 maybe. So I'm going to try x plus 4 times x plus 2. And then I'll check it by multiplying back together. So if you multiply it together, you get x squared plus 2x plus 4x plus 8, which your middle terms, if you combine them, does get you 6x, which is what you needed. So your factored version is x plus 4 times x plus 2. That one wasn't too bad to guess and check because there weren't a lot of factors of 1x squared or 8. We're going to do another one, which this one has significantly more options. So let's see. We know our first two terms need to multiply to get us our x squared term. So they're going to multiply to 12x squared. If I think about things that do that right now, 3x and 4x, 6x and 2x, 12x and 1x. So you can see there are definitely more options this time. And then last two terms need to multiply to negative 4. So not a ton that multiplies to negative 4. Could be negative 2 and positive 2. Could be negative 4 and positive 1, or negative 1 positive 4. So if you put all those different possibilities together, though, there's quite a few guesses and only one of them is going to be correct. So let's see how lucky we're getting today. I'm going to go with, let's try 3x and 4x. It's the first on my list. And then for negative 4, I'm going to try negative 1 and positive 4. So if I try that, multiply back together to check, the 12x minus 4x is going to get me not 13x, so we can eliminate that one. I don't usually erase them because I want to keep track of what I tried. So let me just swap around my 4 and my 1 here. Let's try it this way. So give me, ooh, that's really close. That'll give me a negative 13x in the middle. I wanted a positive 13x, but if I just switch my signs from a 3x minus 4 to a 3x plus 4, and a 4x plus 1 to a 4x minus 1, that should reverse my signs of my middle terms. So that'll give me a negative 3x and a positive 16x. And that's the positive 13x that I need. So yay, it only took me 2 guesses. If you are not a fan of guessing and checking, and you are more of a person that prefers a procedure or a method, there is one we can use. So what we can do instead is find the 2 numbers that multiply to our coefficient on our x squared times our constant. So in this case, they'd have to multiply to 12 times negative 4, which is negative 48, and they need to add up to the middle term. So it still is going to require a little bit of playing around. So going through things I know multiply to 48, 6 and 8, those won't add up to negative 13, no matter which one you make positive or negative. 12 and 4, again, those aren't going to be 13 apart. 16 and 3, that's 13 apart from one another. I want a positive 13, so I'm going to have to do 16 and negative 3 to add up to a positive 13. All right, so once you found those 2 numbers, your guessing part is over. I'm going to use those 2 numbers to rewrite my middle term of 13x as 16x minus 3x, or plus negative 3x. So it still equals my original expression. That's key. That's the only reason why this works, is 16x minus 3x is still the same thing as 13x. I'm just writing it differently. And then I'm going to leave my 12x squared and negative 4 written as they are. And what I've done is create an expression that has 4 terms that I can use grouping to factor like we did yesterday. So if you look at your first 2 terms here, they share a common factor of 4x. So I'm going to factor that out, which would leave me with 3x plus 4. And then my last 2 terms, I want a factor of 3x plus 4, so I could factor out a negative 1. And that would leave me with a factor of 3x plus 4. And then I can factor out that common factor of 3x plus 4 and be left with 4x minus 1. So my factored form is 4x plus 1 times 3x plus 4. Or your factors could be written in the other order, because it doesn't matter what order you multiply in, same thing. Now, one thing that we haven't had so far is a common factor of all of our terms to start with, but 12, 20, and 8 all have a common factor of 4, so it'll save you a lot of work if you factor that out first, because the numbers you'll be dealing with then will be smaller. So I'm going to factor that out first, and then I'm going to factor my trinomial 3x squared minus 5x minus 2. So I'm going to use that second method again and look for the 2 numbers that multiply to 3 times negative 2 and add up to my coefficient on my x term, my negative 5. Okay, so things that multiply to negative 6, I could do 6 and negative 1. Those are 5 apart, but to get them to add to negative 5, I'm going to have to do 1 and negative 6. So I'm going to rewrite my middle term as 1x minus 6x, or plus negative 6x. And then my 4 on the outside is my common factor that I had to start with. It's just kind of chilling throughout this whole process. So I rewrote my middle term, and then I'm going to factor by grouping. So I'm going to factor an x out of that 3x squared plus 1x. And then I'm going to factor a negative 2 out of my negative 6x minus 2. Then I have common factor of 3x plus 1 for both of them. So my final factored version is going to be 3x plus 1 times x minus 2 times my common factor of 4. Make sure you don't forget that